Right, so we've got the curve C is defined by 3x cubed minus 5x y squared plus 2y to the power 4 equals 15. The point P has coordinates 1, 2, and lies on C. Okay, find the equation of the normal to C at P. Okay, so C of course is our curve, right? And we want the equation of the normal at P. Okay. And the point P is 1, 2. So we can do the same sort of thing again. We're going to just differentiate this first here, right, to get dy dx, and then we'll go into all of this later. All right, so of course we've got a product here, right, 5x y squared. So what I'll do is take this over here, okay, and I'll work out the product differentiation of this. Okay, so we set u to equal 5x, v to equal y squared, so then du dx will equal 5, and dv dx, okay, well of course you differentiate that with respect to y first, then you put a dy dx at the end of it. Okay, so the product rule, then you do v du dx plus u dv dx, so crisscross, so that times that, which is 5y squared, plus then this times this, so 5x times 2y dy dx. Okay, that will simplify to be 5y squared plus 10xy dy dx. Okay, so back to this then, right? Of course, we need to differentiate with respect to x. Okay, so wrt with respect to x. So if we start off with that one there, bring the 3 down, so that'll be 9x squared. This then we've got take away, right? So don't forget it is a take away. We want to differentiate this, but of course we've already done that. Okay, so the derivative of 5x y squared is here, all right? But we're taking it away, aren't we? So put in a bracket, okay, to show that we're taking all of it away. Right, that is important. Just recognize that you are taking it away, so you're taking away all of that result. Okay, plus then, right, this differentiated will be 8y cubed dy dx, of course, and then differentiate 15, of course, is a constant, so it's just 0. All right, so you know, a bit of simplifying going on here now. Maybe we'll just take that out of the bracket. Okay, so the minus applies to both terms there. Equals 0. Now what we want to do, we want to get dy dx's onto one side and the numbers onto the other side. So in this case here now, if you notice I got minus 10xy dy dx plus 8y cubed dy dx. We can factorize out the dy dx there. This will be 8y cubed, take away 10xy dy dx. Okay, so I'll just put them together and factorize it, and take then all the rest of the other side. So 5y squared, take away 9x squared. Okay, if we take that over the other side, and then dy dx will equal 5y squared minus 9x squared over 5y cubed minus 10xy. Okay, now what we can do now is work out dy dx at P, right? So at P has that coordinate, so at P 1, 2, dy dx will equal 5. Okay, chuck it in, chuck the value of x and y in, so you've got y is 2, so it'll be 2 squared minus 9, x is 1, so 1 squared, and then 8, so you've got 2 cubed down here, take away 10, x is 1, y is 2. You'll notice I'm just using brackets just to show what I'm substituting in, so it's quite clear. So we can do this in one go. Alright, so get your calculator, so press the fraction button, and we've got 5 bracket 2 squared, oops, I've done that, minus 9 times 1 squared, okay, on the top. On the bottom then we've got 8 bracket 2 cubed, minus 10 bracket 1 bracket 2. So exactly what we've got here. Let's just double check I've typed everything in right. Does it look right? Yeah, that'll do, and it looks good. So press equals, and you come up with a quarter. Okay, now that is the gradient of the curve at P, right? Right, so the gradient of the curve at P is 1/4. But don't forget, the gradient of the curve is ultimately the gradient of the tangent, isn't it? Yeah? Okay, gradient of the curve is the same as the gradient of the tangent. Now we want, what's the question? We want the equation of the normal, okay, to the curve at the point P. So we want the normal. So remember with the normal now, if you've got your curve, for instance at that point P, 1, 2, your tangent obviously just touches at P. Okay, so this has got the same gradient, yeah, as the curve. So the gradient of the curve there, dy dx, is 1/4. And that's the same for the tangent. It's exactly the same, isn't it? 1/4 for that tangent as well. Now the normal, of course, if you remember the normal, okay, it goes at right angles to the tangent. Okay, so that's the normal. So we want the equation of the normal, which is at right angles to this tangent. Now, of course, if we know the tangent to be 1/4 gradient, we can get the gradient of the normal by doing that formula we remember from C1. Okay, so we've got 1/4 for the tangent. Okay, and then we can get the gradient then of the normal to be -1 divided by that 1/4. And of course, if you've got a fraction at the bottom, you can flip that up. So you get -4. Now that will be the gradient of the normal. If that makes sense. So the normal is going perpendicular, right angles to the tangent. Okay, so -4 there for the gradient of the normal. So we've got the gradient of the normal. We've also got the point 1, 2. So we can work out now our equation of the normal. Okay, so the equation of the normal. Okay, so if we use the equation in this format, y minus y1 equals m, x minus x1. So then it's going through the point P, of course. Remember now, to get an equation, you just need a point that it goes through and the gradient. So it goes through P, so that'll be 2 gradients -4. Okay, so we've got that. Let's simplify this. Okay, and then maybe y plus 4x equals 6. Okay, and you've got your equation of the normal.